Hi, this video will discuss marginal substitution, both what it is and provide an example to show you how you would find marginal substitution and why it changes along an indifference curve. So, marginal substitution, what is it? It's simply your willingness to swap or trade between goods. And your willingness to trade also depends on how much of the good that you currently have. So, for example, at bundle A, your willingness to swap burritos for more pizza differs from at point B, when you have fewer burritos and more pizza, and continues to change at both C and D. So once again, what is marginal substitution? It's your willingness to trade between goods that leaves you on the same indifference curve, or the same amount of happiness. All right, more precisely, let's define a marginal substitution. It's the most of one good that a consumer is willing to sacrifice to obtain one more of another good. Marginal substitution mathematically is found as this absolute value of your change in burritos, recall that burritos was on the y-axis, divided by your change in pizza. Recall that pizza was on the horizontal axis. So again, marginal substitution is this absolute value of your change of burritos for your change of pizza. This is also the absolute value of the slope of the indifference curve. Let me provide an example. Here's the visual. Currently, suppose you have 8 burritos and you have 3 pieces of pizza. And the question is, how many burritos are you willing to trade to get another slice of pizza? And of course, when you have 8 burritos, you're willing to give up quite a few to get another slice of pizza. So suppose you're willing to give 3-for-1 trade. 3 burritos to get one more slice of pizza. In that scenario, now after the trade, recall you're no better nor no worse off. You're on the same indifference curve. You now currently have 5 burritos and 4 pieces of pizza. Now the question is, how many burritos are you willing to trade for one more slice of pizza? You no longer want to do 3-for-1 anymore because you're running out of burritos if you keep making that 3-for-1 trade. So now maybe it's 2-for-1. So at 2-for-1, you're left with 3 burritos and now 5 slices of pizza. Now the question is, what are you willing to trade for another slice of pizza? Now you're running low in burritos and you're willing to only give up 1-for-1. So you make a 1-for-1 swap. Now you're left with 2 burritos and 6 slices of pizza. Recall, all of these bundles are on the same indifference curve. So you're neither better nor worse off after making all of these trades. Let's show this on a graph. Here's our initial bundle, point A, where you had many burritos, 8, and only 3 slices of pizza. And you're willing to move to point B, bundle B, by doing a 3-for-1 swap. And at point B, you're willing to only go 2-for-1 swap. Give up 2 burritos for one more slice of pizza. Okay, so this initially is our MRS of 3 at bundle A for Joe. And now at bundle B, you want to go 2-for-1. So now the curvature has dropped to 2 to make that trade. Recall, you're still in the same indifference curve. Finally, at point C, you're willing to go 1-for-1. One more burrito I'm willing to give up to get one more slice of pizza. Here, Z represents pizza and B represents burrito. So, this is the MRS. It changes. At point A, it's 3. At point B, it's 2. At point C, it's 1. So to summarize then, we've seen that the marginal substitution MRS diminishes. As you have more of one good, good X, and less of the Y good, your willingness to swap Y for X decreases. The marginal substitution will always decrease as you get more of the X good, in this case, pizza. Your marginal substitution will approach 0 as you move down to the right along the indifference curve. This is marginal substitution, the rate of trade between 2 goods, and shows you why it diminishes as you get more and more of the X good.